สวัสดีค่ะอาจารย์ทุกท่านค่ะ
สวัสดีครับอาจารย์นะครับ
ค่ะก็วันนี้ก็เป็นการสอบนะคะ proposal ของนักศึกษานะคะต่างชาตินะคะชื่อนะคะพิรุณเรย์นะคะหรือเรียกว่ามีนิคเนมว่านนท์นะคะค่ะ
ครับ
ค่ะขอบพระคุณนะคะมีท่านอาจารย์ธรรมเลศนะคะเป็นประธานกรรมการนะคะแล้วก็อาจารย์วิทยานะคะแล้วก็อาจารย์มาริกานะคะค่ะนนท์ so we have four committee to going to ask you the question so first of all อาจารย์ธรรมเรศ okay อาจารย์วิทยา
อาจารย์
and มา
สวัสดี
ริกา
ครับอาจารย์ทุกท่านครับ
and then before we going to ask you the question I would like you to show and present your research proposal to the committee
เชียบอาจาร
maybe
ย์ครับ
about less than 35 minutes or something try to make it okay
โอเค
yes
ครับ
okay you can show your PowerPoint now
เดี๋ยวอาจารย์เชิญ
you can speak present now okay อาจารย์คะเดี๋ยวจะให้นนท์พรีเซนต์ประมาณเกี่ยวกับ research proposal ประมาณ20ถึงนาทีนะคะไม่เกินนั้นนะคะค่ะ
Okay อาจารย์ did you see my PowerPoint slide
Yes.
Okay now I start the presentation อาจารย์ Okay first of all I would like to respect to Associate Professor Dr. Judemat Bunthai Iwai. She is the head of the Department of Soil Science and Environment, and she is my advisor. And Associate Professor Dr. Thamret Chuswati. He is the head of the committee, and Associate Professor Dr. Uh, Vidya Trilogist, and Ajahn Dr. Mandika Sisutham. My name is Pirunlai. I'm from Cambodia. I'm studying the master degree of Science in Soil Science and Environment. Today I'm so honored to present the research proposal on the utilization of swine wastewater for increasing biomass of Arzola microphylla and application in the vermiculture. And this is the outline of the presentation. One is the introduction, two is the literature review, three is the research objective, four is the conceptual framework, and number five is the experiment one and methodology, and number six is the experiment two methodology, and number seven is the anticipated outcome, and the last one is the research plan. And for my research divided into experiment, the experiment one is application the swine wastewater in to increase the biomass of Azolla. And for the experiment 2 is application the Azolla microphylla in vermiculture. As we know nowadays, the demography and the development are being increased from year to year in the world, that they need the high requirement of the fresh water while the fresh water are limited. Therefore, insufficient fresh water will be occur around the world. And furthermore, the climate change is also the cause of water scarcity. That recently it has been occurred in the Laos, Vietnam, Cambodia, and Thailand as well. That because of the lacking of the uh, previous rainfall and with the warming up with the high population. And besides this, the agricultural activity is also accounting for 70% of the global water consumption, and it could be reached 95% for some developing country in the world. That is the significant player of the water pollution as well. And among the agricultural activity, the swine farm it also consumes much fresh water, that approximately 15 liters per animal per day, that it could discharge the wastewater with the contaminant and the heavy metal as well. And the heavy metal in the swine wastewater, it could cause the water, soil, and the crop pollution or contamination. Otherwise, the copper and zinc It also could be as the micronutrient for the plant grow as well. In case it less than 0.2 ppm and 2 ppm respectively. Moreover, the contaminant in swine wastewater, it could cause the problem to the human health as well, like the nitrate. When the too much of the concentration of the nitrate in the bloodstream of the human, it could cause the blue baby syndrome. Meanwhile, the azula is an aquatic fern that could remove the nutrient and the contaminant from the wastewater by successfully. And it is not only used in the treatment of wastewater, but it also as the source of the nutrient and the protein as well. Azula, it could be used as the feed for the livestock, used as the biofuel, used as the biofertilizer, food for human, mosquito control, and the wastewater treatment, and the other the usage. According to the some literature that they have applied the azula in the treatment wastewater, they have do it by successfully, do mostly in 21 to 28 days, and the wastewater sources mostly from the domestic, municipal, commercial, and the agricultural activity. And the result is show that the azula it has the efficiency in remove contaminant from 41% to 100% as well. And this literature they show that all the species azula in average they contain the crude protein and the high of the nutrient in the azula species. And this literature is also show the same the previous literature. It has the high the protein and the nutrient in the azula pinnata as well. And for this literature, they have applied the azula species like the azula filigulate, azula pinnata in a different concentration of the carbon dioxide, and the result is show that the high of the concentration of the carbon dioxide 800 ppm, it could cause it could contain the protein estimate is so high as well. And for this literature, they have studied about the effects of the fertilizer level and the shade type of the sunlight. And the result is show that for the high nutrient, for the high level of the fertilizer, it could contain the protein and chlorophyll and other nutrient in the high, if compared to the no nutrient. And for this literature, they have studied about the tolerance of the azula species in the saline solution, and the result is show that the azula microphylla is the good one that could produce the much biomass if compared to the other species. And for this literature, they show about the classification of the earthworm in the well-known family that mostly used in the vermiculture, then divided in 5 family. And this is the famous species that are mostly used in the vermiculture. There are 3. One is the tiger worm, the 2 is the African night crawler, and the 3 is the red worm. And the earthworm is the good candidate that could convert the organic waste into the fertilizer as well. And according to the previous study, they apply the Indian blue species of the earthworm in the vermiculture and in the seaweed and the cow dung compost. And for the result, it showed that the earthworm it could be increase the fertilizer the nutrient after the experiment. And this is the beneficial economic cost of the product of the vermiculture, that we could sell the vermicompost, and the earthworm as well. According to the background and the problem that I have mentioned, therefore, the study focused on the feasibility of the applying swine wastewater to increase the biomass of the Asula microphylla, and application the Asula microphylla in the vermiculture for producing the vermicompost. And for the study, I divided into 6 specific objectives. One is to monitor and compare biomass production of the Asula microphylla by swine wastewater. Number 2 is to identify the efficiencies of the Asula microphylla in removal of contaminant from the swine wastewater. And then number 4 is to determine the suitable timing to harvest the biomass of Asula microphylla. And number 5 is to analyze the nutrients and protein in the Asula microphylla, which derive from the cultivation in the swine wastewater. And the last one is to study the nutrient quality of the vermicompost by using the Asula microphylla. This is the conceptual framework of my study. That firstly, we got the swine wastewater, and then apply to increase the biomass of the Asula. In simultaneously, the Asula could remove or could absorb the nutrient and the contaminant from the wastewater as well, swine wastewater as well. And for the experiment 1, we study about the feasibility of the Asula production and treatment swine wastewater, and identification optimum surface area, and determination of the timing for the harvest. And for the experiment 2 is application the Asula microphylla in the vermiculture, and we got the vermicompost with vermicast, like the vermicompost earthworm and vermicompost tea. And then we analyze the nutrient and the quality, and finally we will got the high nutrient and the fit for animal. And for the experiment 1, that we will apply the swine wastewater to increase biomass of Asula. I got from this farm. It's locating in the Nong Tum commune, Nai Mueang district, Khon Kaen province. And the Asula microphylla, it has been being cultured in the practical farm of the Department of Soil Science and Environment in the KKU. And for the experimental design, I follow the completely randomized design, and we prepare the 18 plastic plots in depth 0.3 meter with the various size. And this experiment, it will be conducted with the 6 treatment and 3 replication. And the studies will inoculate the Asula microphylla 159 gram per plot respectively. And for the treatment 1 to treatment 3 is the control that using with the tap water, and treatment 4 to treatment 6 is the using with the swine wastewater in 15%. And this is the experimental arrangement that I prepared. And for the parameter, physical property, I will analyze the biomass of Asula, temperature, EC, TSS, TDS, DO, BOD, COD, pH, protein, nitrate, nitrogen, available phosphorus, total nitrogen, total phosphorus, potassium, calcium, magnesium, iron, copper, zinc, and manganese. And for the data collection, most of the parameters will be gathered every 7 days within 21 days, and exception the total nitrogen, total phosphorus, potassium, calcium, magnesium, iron, copper, manganese, and the zinc. It will be collected before and after experiment. And for the efficiency removal of the contaminant, I will follow the formula below, the adapted from the Taylor et al. 2015. And for the experiment 2, application the Asula microphylla in the vermiculture. For the raw material, I got the cow dung obtained from the cattle farm in KKU, and the earthworm, African night crawler, which has been raised in the Research Developing and Learning Center on the Earthworm for Agriculture and Earthworm in KKU. And I will inoculate the Asula microphylla and cow dung at the ratio 50-50 in the plastic bucket. And inoculation the earthworm African nigrella 15 per bucket of the total amount 3 kg within 45 days. And the experimental design will follow the COD. And the treatment 1 to treatment 3, I is the control that without the inoculation of the earthworm. And for the treatment 4 to treatment 6, inoculate with the earthworm African nigrella. And for the parameter of physical properties, I will analyze the EC, weight of the earthworm, and the cocoon. And for the chemical property, I will analyze the pH, organic matter, crude protein, CN ratio, total nitrogen, available phosphorus, exchangeable potassium. Yeah, for the data collection, all the parameters will be analyzed before and after experiment. Anyway, moisture and the temperature will be monitored and controlled every 7 days within 45 days. And for the data analysis, I will use the statistic 10 program version 10 and mean comparison tool with the confidential interval 95%. I will based on the LSD procedure. Anticipated outcome. I deeply hope that optimal surface area timing it will be identified, and Azolla microphylla will contain the high nutrient and the protein for the crop and animal feed, and the saline wastewater would be the good source of the nutrient and the safe for irrigation, and the vermicompost it would be provide the high nutrient for the crop, and the last one is the earthworm it could be sold on the market. And this is the research plan that I will start from the August of the 2020 or 2019 until May of the 2021. And this is the budget plan that I had a plan that in the total around 126,000 baht. And finally, I am so gratitude to Her Royal Highness Princess Mahajagri Srinthorn that providing me the full scholarship for 2 years in the master degree. And I am also highly thankful to my advisor, Associate Professor Dr. Chulama Bunthai Iwai, that always provides me the good consultation, taking care and providing the supporting supplement finance as well. Okay. Thank you so much.